Hello guys, welcome to the first video in a series that's going to cover the Cambridge IGCSE syllabus. Today we are going to work on Chapter 1, States of Matter, in the Cambridge IGCSE Chemistry 5th edition book. So first, how can you follow along with this lesson? You must take contents of the you must take notes of the contents in bold in your own words and copy the diagrams if any, and that's all. Now let's get into the table of contents and start this lesson. So first, we are going to go into state of matter, then changes in state, then pure substances, heating and cooling curves, atoms and molecules, kinetic particle theory, mixtures and solutions, and finally, diffusion. First, let's get into states of matter. There are many different kinds of matter, and whatever it exists in three different states of matter, either solid, liquid, or gas. Next, the properties. Each different state of matter, they have certain general characteristics that are always true no matter what the substance is. For example, a solid always have a fixed volume, a high density, a definite shape, and does not flow. A liquid always have a fixed volume, a moderate to high density, no definite shape, and flows quite easily. A gas, on the other hand, has no fixed volume, low density, no definite shape, and it flows extremely easily. Next, I'm going to talk about changes in state. So, between the three basic states of matter, there's gas, liquid, and solid. Um, by an order of increasing temperature, first a solid melts into a liquid, which evaporates into a gas, and in turn of decreasing temperature, a gas condenses into a liquid, which freezes into a solid. And also, if a solid just went straight to a gas without passing the liquid state, then we call it sublimation. And if a gas went straight to being a solid, we also call it sublimation. Next, I'm going to talk about pure substances. It consists of only one substance without any impurities. The boiling of melting point of a pure substance are precise and predictable, and impurities often affect the value of the boiling and melting point of a substance. For example, we have seawater. Its freezing point is way below 0 degrees Celsius, while its melting point is impurities often affect the value of the boiling and melting point of a substance. For example, seawater. Its freezing point is less than 0 degrees Celsius, and its boiling point is way more than 100 degrees Celsius. It's also the same with other substances containing impurities. Next, I'm going to talk about heating and cooling curves. Using this apparatus, we could monitor the temperature changes every minute while heating and cooling. It consists of oil or water to use as a medium to transfer heat, a solid in a melting point tube, a thermometer to measure the temperature of the solid, and then the rubber band to band the melting point tube and the temperature together. And there's also a stirrer just to hold the temperature and melting point tube together extra tight. And using this data, we could make a heating or cooling curve. For example, in this cooling curve, first, in A it was a gas, and then in this horizontal part, it was condensation is happening, and then in this part is liquid, and in this part is freezing, and in this last part is solid. And note that while undergoing a state change, the graph is flat. This is because the temperature change that is lowering is is battled against by the heat or the taking in heat of forming or breaking bonds. Next, I'm going to talk about atoms and molecules. Our modern understanding is based on the idea that all matter is divided into small particles known as atoms. Atoms means inseparable in Old Latin, and each element is composed of its own type of atom. Atoms of different elements can combine to make the molecules of a compound, and because of this, we have the kinetic particle theory, which basically says that all matter is made up of very small particles. Particles are moving all the time. The freedom of movement and the arrangements of particles is different for the three states, and the pressure of a gas is produced by the atoms or molecules hitting against the walls of the container. Next, let's talk about mixture and solution. Each mixture must be made from at least two parts, and a solution is a solute dissolved in a solvent, which is basically a type of mixture. And in common use, water is the most common solvent. And most other solvents are organic liquids, and those are I mean, those are extremely useful because they can dissolve stuff that cannot dissolve in water. And the more solute they are, the more concentrated the solution is. And reverse, we have the less solute they are, the more diluted the solution is. And when no more solvent will dissolve, the solution is saturated. And solubility of most solid increase with temperature. Next, we have diffusion. Particles move from a region of higher concentration towards a region of lower concentration, and eventually the particles are evenly spread. Their concentration is the same throughout, and the rate of diffusion in liquids is much slower than in gases. And diffusion does not take place in solid at all, as the particles cannot move from one place to another. Next, let's talk about diffusion in gases. And there are some important points that we get from the kinetic particle theory. That is, the heavier the gas particles, the more slowly it moves while diffusing, and the larger molecules diffuse more slowly than the smaller ones. The rate of diffusion is inversely related to the mass of the particles, which is basically the first statement. And then we have the average speed of the particles increase with an increase in temperature. And that's all the knowledge you need to know. Now I'm going to work this. I'm going to show you a work example that I did, and then I'm going to give you two practice problems to practice by yourself. And then I'm going to give you guys a summary of this subject. So first, this work example basically shows you a cooling curve and asks you what is happening between C and D, what is happening between A and B, and why does the temperature not change between B and C. And as aforementioned, between C and D, the substance is solid and is cooling down because it already passed its melting point, and the particles is moving more slowly and moving closer together because they lose heat between A and B. And the reason why there's no change in temperature between B and C is because the substance is changing state, and the heat is created by the formation of bonds between particles counteract the cooling of the temperature. So now I'm going